In this video, there are three curves x, y, and x, t, vt, and at of this car. The car will be accelerated uniformly, the speed will increase uniformly, acceleration will be constant, and let's start the curve. See, the acceleration is constant, velocity is increasing with a constant slope because the slope of the velocity is acceleration, which is constant, and xt is increasing parabolically. Xt is a parabola. Whenever acceleration is constant, xt is parabola. You can also look at the separation. This is x, the next distance will be 3x, and the next distance will be 5x, then 7x, 9x, and so on. This is called law of odd numbers given by Galileo. So it stays as if the initial velocity is 0 and the acceleration is uniform, in equal interval of time, the distance or the displacement travel will be in the ratio of 1:3:5:7:9, and so on. So this is shown by the video. Xt parabola, Vt straight line, At is a constant curve. Now again moved it, and now I have kept the acceleration 0. You can look, the acceleration 0, velocity is constant, and Vt curve from this point, xt curve will be a straight line. So xt is a straight line because the slope, which is velocity, is constant, and the slope of velocity time curve, which is acceleration, is 0. So velocity is constant and xt is a straight line curve with a constant slope. Velocity is positive, slope is positive. So let's move the car, and now again the car start retarding. Acceleration is not negative, which is not visible in this video, and velocity start decreasing. The slope of the velocity is negative. Xt will be a part of parabola which is opening downward. Xt will be a part of parabola which is opening downward. Here it was a part of parabola opening upward because the acceleration was positive, velocity was increasing, xt was upward opening parabola. And when acceleration was 0, velocity was constant and xt was a straight line. And when acceleration is negative, velocity decreases with a negative slope, and xt is a part of downward opening parabola. Okay, so let's move the car. Then in this video we'll be showing acceleration and velocity on the car. Velocity is the direction in which it actually moves, and acceleration decides what will happen to the velocity, whether it will increase or decrease or change its direction. If acceleration and velocity are in same direction, velocity will increase, and if they are in opposite, the magnitude of velocity will decrease, and if they are perpendicular, then it will change its direction, or the component of acceleration which is perpendicular is responsible for changing direction of velocity. So let's move the car. Again, you can look that acceleration was in the direction of velocity, so speed increases. Now the acceleration is perpendicular to velocity. You can have a look. So the car moves towards the direction of acceleration. The velocity tries to remain in the direction of acceleration, again on the opposite direction. So again increases, and now this is an important, as acceleration will have two components, one perpendicular to velocity and another in the opposite direction to velocity. Perpendicular component will steer the car in this direction, whereas the component of acceleration which is opposite to the velocity will decrease its speed. This perpendicular component will steer and this opposite component will decrease its speed. Now the car is retarding as acceleration is opposite to the direction of velocity, and finally it will stop if the time passes by. Now this is another video in which there will be two cars. One will be starting with some initial velocity and another will be starting from rest with a constant acceleration. The one who has some initial velocity will be moving with that constant velocity. It will not have any acceleration, and the car which will be accelerating will after some time will overtake the car which has no acceleration, just initial velocity. At the time when they crosses each other, the speed of the car which is accelerating must be more, but the displacement traveled by both the car should be equal. Let's move the video. This red car has an initial velocity and no acceleration. Blue has no initial velocity but acceleration. You can see zero initial velocity, but rate of change of increase of velocity is constant, which is acceleration, and it has constant velocity, zero acceleration. You can say constant velocity. Xt will be a linear curve for the red car, whereas xt will be a parabolic curve for the blue car. You can look at this point. The separation for the certain time increases till the moment both the cars have same velocity. If the velocity of blue car is same as the velocity of red car, then the separation will be at that moment will cease to increase, and after that it will decrease. Look, the separation is decreasing now, and at this moment when it just overtakes, x will be same, this x will be same as this x, but velocity of blue will be more than the velocity of red because it is overtaking the car. Okay.